This conference will now be recorded.
Okay, in this video, we are going to look at the rectangular coordinate system, and specifically, we have two formulas we're going to go over, the distance formula and the midpoint formula. Before we get to those, though, just a quick review. You can see right here on our screen, we have a little rectangular coordinate system. Again, you've seen this before, but this horizontal axis, that's our x-axis, and the vertical axis would be our y-axis. We can locate any point on this coordinate plane by using an ordered pair. The x value comes first and the y value comes second. For example, if we wanted to find the point 3, 2, that would be an x value of 3, so we would go over 3, and a y value of 2, so we would go up 2, and that would be the point A. Same thing, if we have negative values, we could have the point -4, +1. Then we would go from the origin to the left 4, -4, and up 1, there's point B. We could have a point in the third quadrant. That would be where both x and y were negative, -2, -2, that would be about right there. And then we could have a point over in the fourth quadrant, maybe a positive x value and a negative y value. So +2 and -4, that one would be here. I'm sure you've seen a coordinate system before and are used to ordered pairs. That should just be review. The first formula that you need to know from this section is the distance formula. And this formula tells you how to find the distance between 2 points. What we have here is if we had some point, we'll call this one P1, and P1 has the coordinates x1, y1. And then we have another point somewhere else, say P2, and that point has the coordinates x2, y2, and we are looking to find the distance between these 2 points, so basically how long that red line is, and that's what we use this formula for. This formula is derived or proven from using the Pythagorean theorem. If we were to turn this triangle into a right triangle, it turns out that the length of this side can be represented by the absolute value of y2 minus y1, the difference between the y values. And then the length of this side can be represented by the absolute value of x2 minus x1. And when we put that all together, if we would use the Pythagorean theorem, a squared plus b squared equals c squared, where c would be the red side, we could derive this formula. You don't really need to know how to derive the formula. I just wanted to give you a basic idea of where that came from. So we will first use that formula just to answer the basic question here. Find the distance between the 2 points given. They gave us point A and point B. Let's just see what that looks like really quick in a picture. The point A, -4, 5. So that would be about here. And the point B is at +3, -1. So that would be about here. So we are looking for the distance between those 2 points. One of the things I tell my students when you are asked to use the distance formula, it might help you to memorize it for tests if you just write down the formula every time you're going to use it. So here's our distance formula, just copying it down from the previous page. Okay, and we want to apply that to these points A and B. I usually like to designate one of my points number 1 and one of my points number 2 can help you fill in the values in your formula. So x2 would be, in this case, the value 3 minus x1, -4, plus y2 minus y1. There's our formula with all the values filled in, and then we just need to go ahead and simplify as much as possible. Be careful with your signs, be careful with your order of operations. So here we end up with 3 minus a -4, so that's 3 plus 4, or 7. -1 minus 5 is -6 squared. Got to make sure you square that negative sign and the 6. So here we end up with the square root of 49 plus 36, which is the square root of 85. That is not a radical that can be simplified, so we'll leave it there, but you would simplify that radical if possible. Another type of problem we would see with the distance formula is one that looks like this. This example says find all the points on the x-axis that are a distance of 6 from the point 7, -5. Okay, so let's take a look at what that, let's not use that pen, that's not a good one. Let's take a look at what this question is asking us to do. So they gave us the point 7, -5. So that would be about right here. Okay, and if we were asked to find every point that is 6 units away from this point, what we would get is we would get a circle with a radius of 6. So it would look something like this. I'm not very good at drawing a circle, but you get the idea. Every point on that circle would be 6 units away from our given point. But it did not ask us to find every single point that's 6 units away. It asked to find all the points that are on the x-axis. So we are trying to find this point and this point. Those 2 points are both 6 units away because they're on our circle, and they are both on the x-axis. So we need to use the distance formula. We need 2 points. We have the one given in the problem, and then we have these 2 little green points that I labeled here. For either one of these points, I'm just going to arbitrarily pick one. We don't know the x value of that point, but we do know the y value. If it's on the x-axis, the y value has to be 0. So these would be the coordinates of one of those points on the x-axis. Now we can use the distance formula with the point they gave us in the problem, the point we labeled it on the x-axis, and the distance that we've been given in the problem. So here's what we have. 6 equals the square root x2 minus x1. It doesn't matter which order we put it in as long as you stay consistent with your order. y2 minus y1. And here's our equation. We need to solve for x. So the first thing we might want to do is get rid of this big old radical on the right. We can remove a radical from an equation by squaring both sides. So if we square the left, we get 36. If we square the right, that just cancels out that radical. I'm also going to simplify this second term here, negative 5. So those 2 minuses cancel each other out. We get 5 squared, which is just 25. From here, we need to solve this quadratic. One choice would be to square out this binomial. We could use FOIL to multiply that out, then get one side to be 0, and then either factor or use the quadratic formula. It turns out that a quicker solving technique for this one is going to be to use the square root property. So 36 minus 25 is 11. Now we're trying to get rid of an exponent. So instead of squaring both sides like we did at the beginning, we are going to take the square root of both sides. Don't forget when we take the square root to throw in that plus or minus. And finally, we would add 7 to both sides. So our final answer here for x could be 7 plus the square root of 11, or it could be 7 minus the square root of 11. And what that means for our 2 points that we labeled up here on our graph, one of these is going to be 7 minus the square root of 11, comma 0. So that's the x coordinate that we just found. And the other one is 7 plus the square root of 11, comma 0. Okay, we typically want to leave our answers in that radical notation. We call that exact notation. If we wanted an estimate, we could plug that into our calculator. I did do that really quickly. This one is approximately equal to 3.70, and this one is approximately equal to 10.30. And you can see that might roughly match my picture. My picture probably wasn't exactly to scale, but that's how we're going to go about solving. I'm underlining in red. Those would be our final answers solving a problem like this. Okay, the next example is very similar, but instead of finding all the points on the x-axis, let's see if I can get scroll. There we go. We're going to find all the points on the y-axis. So again, let's start off with a little picture over here. Our point this time is +3, +2, so it's about there. And we are looking for all the points that are a distance of 4 away from this point we were given. So again, all the points that are 4 units away would make a circle. This time they are asking us for only the points on the y-axis. So that would be this one and this one. And they told us that that distance in this problem is 4. Okay, so again, we want to label these green points. This time we're not on the x-axis, we're on the y-axis. So that means the x-coordinate is 0, and the y-coordinate is our unknown. It's going to be our variable in the problem. So again, using that distance formula, I'm just going to copy it down for you first. Okay, then we plug in that what we know, the distance that we've been given is 4. x2 minus x1, I didn't label my point this time. Point P was 3, 2. It doesn't matter, so these are the 2 points we're going to use, this one and this one. It doesn't matter which one we call 1 and which one we call 2. I usually like to make, I like to have my variable first in the subtraction, so I usually call this one 0.2 and this one 0.1. It doesn't really matter. So x2 minus x1 plus y2 minus y1. From here, the solving technique is exactly the same as the last problem. We can square both sides. And I'm also going to simplify in here when we do that. Then we'll subtract 9, 16, 16 minus 9. Sorry, I was looking at my notes. 16 minus 9. Oh no, what happened? 16 minus 9 is 7. Take the square root of both sides. Don't forget the plus or minus. Then we add 2 to both sides. There's our solution. Again, that corresponds to 2 points. So the 2 points that we are looking for, they both have an x value of 0. And the lower one, the bottom one, would be 2 minus the square root of 7. The upper one, the top one, would be 2 plus the square root of 7. Okay, so that pretty much covers the distance formula with a couple of examples. In this section, we also are going to cover the midpoint formula. I think the midpoint formula is easier to remember than the distance formula because here's what you have to think about. If we're looking for the midpoint, that means we are looking for the point that falls in the middle or in between 2 other points. So if these are our 2 points given, if we drew a line connecting them, the midpoint would be smack in the middle of that line right there. That would be our midpoint. Okay, so the midpoint formula, although you can memorize x1 plus x2 over 2, it's easier if you just think about the fact that the first coordinate of your midpoint formula is the average of the x values. And the second coordinate of your midpoint formula is the average of your y values. I try not to memorize formulas whenever possible, but just kind of think about the problem. Average up your x's, average up your y's. That's going to give you your midpoint. So in this midpoint example, we are given 2 points. Our first point is -2, +3. And our second point is +4, -2. If we connected those 2 points with a line, we are looking for the point that falls right in the middle. So we are looking for the coordinates of that point right there. That's what the midpoint formula will give us. So the midpoint formula, take the average of the x values. So -2 plus 4 divided by 2. That's the x coordinate of your midpoint. And then you average your y values. 3 plus -2 divided by 2. And that's the y coordinate of your midpoint. A midpoint will always be an ordered pair. And from there, we just need to simplify. -2 plus 4. And 3 plus a -2. And finally, we can reduce that first one, our midpoint, as it's a 0.1, 1/2. And that's it for this section.